So as we get towards competition, when theta is equal to 0, firms internalize average costs, right? Just as we got before when we talked about regulation, right? Under monopoly, they internalize average cost. So that's the benefit of monopoly, is that they are taking into account the effect that they have on the costs in the industry, right? But the cost is that they also take into account the effects that they have on the revenue in the industry, right? Through the changes in prices, right? So this gives us a weighted average of demand, marginal revenue, average cost, and marginal cost. So Mike, how would we solve for the socially optimal value of theta in this context?
You want to look at how theta as it changes affects the consumer surplus and social welfare and things of that nature. So,
well, we know that the socially optimal thing is what, Mike?
Competition.
No.
So
well, no, right? Because we know that competition can be harmful under selection, right? But well, what do we know? What's the optimality condition?
I'm not really too sure.
Anyone else want to? Eric, you want to try?
Is that just price equals marginal cost?
Yeah. So how could we solve for the optimal?
Well, you can take that equation from the first order condition.
Yeah.
Right? Just plug in P equals MC for MC. Probably solve the left side out for P to get something, and so the different values of theta will give you different values of P that make that equation hold.
Exactly.
So you just want to set theta such that P equals MC.
Yeah, so you could just literally put MC in these two spots and solve for theta, right? And under adverse selection, Daiichi, what do you think that that's going to lead us to find? What's going to be the optimal market structure under adverse selection when the marginal cost is below the average cost?
It would be the same as what you would find in perfect composition.
Yeah, so it would be theta is equal to 0, right? Because that's the competitive arrangement. The way that you can see that is that if we try to make theta more positive, right, that's going to increase the weight on MC, decrease the weight on AC, and that is going to lead to a lower, that's going to lead to a higher price, right? Because we know that under perfect competition, the price is at average cost, right? And that is not going to earn any firms any profit, right? So the firms are always going to have to raise their prices as they get less competitive because they're going to have to make some profits, right? Now, under advantageous selection, the things are a little bit different. You can actually do this at home, but if you solve out for what you get, the optimal value of theta star is the difference between marginal cost and average cost over the marginal surplus plus the difference in marginal cost and average cost. And the reason why, in adverse selection, marginal cost is below average cost, so this is negative. This is a negative number here. And this is positive, so you'd actually like to set theta to be a negative number, which you can't do, right? Whereas under advantageous selection, this is a positive number and this is a positive number, as is marginal surplus, and so there's some optimal value of theta that's in between 0 and 1. And that sort of makes sense because remember that we found that perfect competition gave you too much relative to the social optimum under advantageous selection. The social optimum is where demand is equal to marginal cost. Where demand equals average cost is too high of a quantity. Where marginal revenue equals marginal cost is too low of a quantity. The optimum is somewhere in between, which can be achieved by taking a convex combination of average cost and marginal cost and of marginal revenue and price. Okay. Yeah?
In that first order condition, if you substitute theta equals 0 in, don't you get that price equals average cost solves that equation?
Exactly. That's why that's not going to be optimal, right?
Okay, yeah.
Under, unless average cost is equal to marginal cost, which is that there's no selection distortion.
Didn't you? Oh. Okay.
Yeah.
Never mind. Okay.
Yeah. OK. So now let's introduce design distortions. And to do that, let's focus on the differentiated Bertrand model. So imagine that firms have the same cost of serving any consumer given the level of non-price quality that they choose, right? And let's imagine that there's a symmetric utility distribution in the sense that there are some people who prefer product A over product B, and some people who prefer product B over product A. But for everyone who prefers A over B, there's someone who prefers B over A. So this would be them being on a hoteling line, an equal distance from the center or something like that. And let's look for a symmetric equilibrium in the price and the non-price quality. Now there's going to be two types of consumers who are on the margin in this market. One type are the consumers who are definitely going to buy product A or definitely going to buy product B, but are uncertain whether they're going to buy either product. Sorry. If they're going to buy any product, they're definitely going to buy product A. If they're going to buy product, or if they're going to buy any product, they're definitely going to buy product B. But they're uncertain about whether to buy any product at all, right? So those are people who are exiters to the market, right? There's a second group of consumers who are indifferent between buying the two products, but are definitely going to buy one product. And those are the switchers. And I'm going to denote those two margins, S and X. And by symmetry, I'm going to look at, for symmetric equilibrium, the size of the exiting margin is the same for the two markets, for the two products. And the size of the switching margin is MS. OK. So notice that by symmetry, we can derive the socially optimal conditions in the exact same way that we derive the socially optimal conditions for a monopoly, because we can just think of the social planner as having one product, which is like whichever of the two products you like better to sell, and they're just adjusting the price and non-price characteristic of the product uniformly together, right? And from that perspective, the only thing that matters is the exiting margin, because it doesn't matter to the planner as people switch across buying one product or the other, right? So the optimal thing is going to be for the planner to set, as we derived in the product design lecture, the number of people multiplied by the average difference between their marginal utility and the marginal cost of serving them, equal to the number of people who are along the exiting margin multiplied by the covariance along that exiting margin between people's marginal utility and the cost of serving them. OK. Now, on the other hand, when we think about competition, each of the firms is just going to maximize their profit. And to them, the two margins are exactly the same, right? To them, they're all just part of their residual demand, right? So the private firms are going to do exactly what a profit-maximizing firm is going to do, except they're going to use the two margins now, rather than just the one margin from before. So the profit-maximizing firm sets the number of people times the expected marginal utility of people who are on the margin, either of the two of the exiting and switching margin, minus the marginal cost on average of serving anyone who's buying in the market, equal to the sorting effect, which is along the two margins, both the exiting margin and the switching margin. And you can notice that there's now two divergences between the social and private optima, right? There's the Spence distortion that we saw from before, right? Though here it's a little bit different because the firm is taking into account both the exiting margin and the switching margin. The second divergence is that the social planner only cares about sorting people into and out of the market, whereas the firm cares about sorting people into and out of his competitor versus him. He likes to steal the best consumers from his competitor and leave his competitor with the costly consumers, right? And notice that as the number of people switching on the margin goes to infinity, that's basically the diversion ratio gets very large, right? Everyone's going to be willing to switch to the other firm. This is going to go to infinity, right? This is going to get infinitely large. And that's going to make it impossible for there to be an equilibrium in this market, right? So this is called the Rothschild-Stiglitz market collapse idea. So the idea is that, I can, by offering a little bit lower price and a little bit lower insurance coverage, steal all the healthy patients from you and leave you with all the sick people, right? And that will lead the market to collapse. Okay. So I think this distortion can be pretty important in some context. So one thing it does is it erodes coverage in insurance markets. Another example of this is like workplace things. So a workplace might make a really family unfriendly firm, or like make it really unpleasant for people to work there because they think the people who are the hardest core or who are least likely to have children will prefer to work at that sort of a place, and they'll steal those people from their competitors, right? I think this is one reason why finance firms might make people work such long hours, and one potential reason for workplace regulations, to say that you can't have certain working conditions because those might be useful to cream skim from your competitors, and therefore they might be oversupplied by the market. In fact, Roland Benabou presented a paper recently here at the Booth School about how competition might make bonuses too prevalent, because you're trying to get like the hardest working people, but then you're giving them these giant bonuses, and that might not be optimal either from an insurance perspective because they'd prefer to get more base pay, or because it gives people too much an incentive not to look out for the long-term interests of the company, but just the short-term interests. Okay. I don't think anyone's ever measured any of those effects, though, so I think that's a really interesting research topic. Informational racing in financial markets, another example. Like if I try to figure out what stocks are going to do better to get out ahead of you, right? That's basically, I'm trying to skim the cream off of my competitors, right? And that's wasteful because in the end, it makes like no difference for what we're actually doing. I'm just trying to get a bit ahead of you. Margin call was a great example of that, right? He was trying to be faster than the other firms to get rid of the worst assets, even though that wasn't particularly socially valuable. It was just dumping the losses on someone else. So another great example of this is, I don't know if you heard about the tunnel from New York to Chicago, but they built a tunnel through the earth because if you go over the Earth's surface, the communication has to like take a couple of transit points, and so it takes slightly longer. And you can cut like 4 milliseconds off the transit time if you build a tunnel through the Earth. And like a bunch of hedge funds thought that that would be a way to make a lot of money, to be able to arbitrage the prices 4 milliseconds ahead of everyone else. Another example of this is what happens when there's competition in price discrimination. So giving discounts to grandmas and students, which is what a lot of like movie theaters do, might not be because those people would otherwise not buy the product, right? It might be because those people have the most time to shop around for the cheapest price. And if you give those people a discount, that doesn't actually make anything more efficient. It's just stealing those people from your competitors, right? So I think that this sort of stuff is a very important downside of competition that's